going to start another little video here. So we've got the two circuit diagrams of what we saw there, and what if, it's worth saying now actually that what I said originally was that if it's got a junction like here, then we would say that it's a parallel circuit, and if it doesn't have a junction, then it's a series circuit. However, this can cause a little bit of confusion because someone will say, well, hang on a second, that's a junction. Well, it is a junction, actually. But the thing is, when it comes to measuring instruments like voltmeters and ammeters, they are designed to act as if they're not even there. So, yes, it's true that that is technically a parallel circuit. It's maybe more accurate to say that the voltmeter is in parallel with the battery, and the voltmeter is in parallel with the light bulbs, and so on. However, that is just for the voltmeter and no other thing on the circuit. And so we can kind of forget about the actual the measuring device. In other words, the circuit is just where I'm going, just the highlighted bit. So the wires in the circuit are just these ones here. Those are the ones I'm interested in. The ones that lead to the measuring devices, we're not so interested in. So if we compare that with this one over here, we can see there is a junction that goes on the actual circuit itself that we're interested in. The measuring devices, they're just there because we're trying to get some measurements from it, but it's not going to really actually affect the circuit. It shouldn't do. So it probably will affect it slightly, but we assume that the effect is negligible. Okay, so with that, now let's look at let's put the values for what we just found out they were when we did the experiment a moment ago. So I'll just pause the video and write it down now. So when we took the measurements, we saw that across the in the parallel circuit and in the series circuit, both batteries produced 9 volts. That meant as it went before, if we compare before and after compare the energy the electrons had before and afterwards, they had 9 volts, so 9 joules per coulomb, and that actually means how much energy they gained as they went through the battery. And over here we have a negative 9 volts, and that's because they lost that much energy per charge as they went through the light bulb. Compare that with over here, with this parallel circuit. Again, 9 volts as they went through the battery, 9 volts as they went through both light bulbs, but after they've gone through one, they've lost half of that, and after they go to the second one, they've lost the other half of it. So that's no surprise. So, but in summary, we can say that the voltage total in in series is equal to V1 plus V2. Okay, so we can say that's the first voltage, that's the second voltage, and this is the total voltage here, or that's the total voltage there. Okay, we're ignoring the negatives and positives at this point, I suppose. Well, sort of. Anyway, whereas over here the voltage is the same everywhere. Now, what about the current then? So comparing it now with the current on the parallel circuit, we had 1.8 amps coming through here. That's split up into 0.9 there and 0.9 there. So we can say on the parallel circuit, the total current is equal to I1 plus I2. Whereas, so I is bizarrely enough current. So sometimes in physics we have strange symbols for values, but that's just the way it is. And series, the current is the same everywhere. And again, it's not too surprising because it's got nowhere else to go. So all the electrons are going there, whereas here they split at the junction. So that's why we have this formula here. The confusion thing might be, to start off with, is why is it 0.45 there and none of these are 0.45? And the reason is because it slows down because the electrons have to go through 2 light bulbs, whereas here they only have to go through 1. So they're going to be able to go through it twice as fast here and twice as fast here. And also they're going to then join back together there, and it's going to be 1.8. So it's actually this voltage, this current's going to be 4 times as much as this, and this one is going to be twice as much as that. Okay.